8, we're dealing with different kinds of properties, and properties are just when you describe different things about material or matter. The first type of properties we're going to look at are called physical properties, and when you're doing a physical property, it's basically when you're describing it, you're telling it something that we can observe or very easily measure, but you're not actually changing it. So no explosions, no, you're not lighting it on fire or anything. So if you start with diamond, you would still end with that diamond. So a couple examples of physical properties are any color. Description, hardness, for example, like diamonds are on the hardness scale, the hardest known mineral, and the mass as another example of a physical property. When we're looking at physical properties, there are two distinct types. We have an intensive type, which means it only really matters what type of matter is present, so the amount is not important. So color is an example. All your phase changes, melting points, boiling points, all that kind of stuff are intensive. Density is intensive, temperature, and hardness. So just for example, it doesn't matter if I have 5 grams of ice or if I have 500 grams of ice, the melting point's still going to be the same. And that's the key here for intensive, is that it's almost like internal. The amount isn't going to affect it. On the flip side, extensive properties are dependent on the amount. So these are things you measure a lot of. So mass, length, volume. If I have more of something, my mass increases, and that's an extensive property. On the flip side, we also have chemical properties, which is what we're going to spend most of the time in chemistry on. And what we're talking about is these are changes that then you chemically change what the substance is. So, for example, you can actually burn diamonds. I don't know why you'd want to, but you can. And you can actually change you can actually make a diamond into ash. So just a couple examples of some chemical properties. We know that iron has the ability to rust, and that's a major concern in our world because we use it for so much. We know that milk can turn sour if it's left to sit for too long, and a lot of active metals react with acids and they form actually hydrogen gas, and we'll do that in a lab in not too long. So you just want to be able to tell the difference between the major ones here, the physical, and within the physical you want to know the intensive versus the extensive, and then the chemical properties. Going along with that, we have physical changes and chemical changes. A physical change is just when you actually are changing the shape, you're changing the size, but you're not changing the identity. So the classic example here is like if you have Play-Doh and you're playing with Play-Doh, you're doing a physical change. You're changing what it looks like physically, but it's still just Play-Doh. If I get really mad at you and I rip up one of your papers or I cut it into a million little pieces, each individual piece of paper is still paper. So those would be physical changes. It gets a little trickier with chemicals because it's not as apparent. Sometimes you think something is physical, sometimes you think something is chemical. We'll actually do a lab on it, on identifying them. And what you'll see is that some are very clear cut, some are very simple. Some of them are a little, just looking at them with the naked eye, it doesn't really help us. Every phase change is going to be a physical change. So you're not changing what the chemical actually is. What you're doing is you're changing its arrangement, you're changing its attractions to itself, but you're not actually changing what it's made of. And then last thing on this one is we also have here's just an example of our chemical ones. So chemical ones are the ones where you are changing how it's actually bonded to itself. You're changing what's connected to what. And the big thing here is you're making something new. You're changing its identity. All the pyros out there, like the burning paper example, because you're definitely changing how things are connected. This is one of my favorite ones. We have sodium metal, and you don't think of sodium as metal, but it's a shiny silver metal, and we actually have some, and you have to store it in a back room under lots of locks and keys and stuff because it's very dangerous, and you have to keep it under oil so it doesn't react with the air and the water around it. So you have this metal that's really dangerous, really soft. You react it with chlorine gas, which was used as one of the first chemical warfare. You can actually start attacking your lungs and you can die from it. So we have this chemical that's really dangerous. We have this gas that's really dangerous. If we do a chemical change with them, what we get is we actually get just sodium chloride, which is table salt. So that's one of the cool things about chemistry, is you can really change properties from it. At the end of this one, there'll be like an 8A video. It's just a really cool example of a chemical change, but it works better if I just post that separately as opposed to you watching it here. So it'll be a little one, but it's another one where they show you just a really cool chemical change with thermite, if you've never seen thermite. And the last slide for this video is nuclear, and we will deal with nuclear changes. It is different than a chemical or physical, and this is different because you're actually changing inherently what the element is. So if you start with carbon, you do a nuclear change, a lot of times, not always, but a lot of times you do not end up with the same element at the end. And like the name intends, it does happen in the nucleus, and the classic examples of it are fission, which is what happens at like nuclear power plants, that kind of stuff. We have fusion, which is what happens in the sun and stars. Radioactive decay is a type of fission, and 3 Mile Island is just our closest one. You can see in this picture that we have an element is being bombarded by something, and this is fission, it's falling apart, and you can see the two distinct new things coming out of it. Actually, this one I guess has 3, I think. And then what you can see is this can keep going, so they can keep making it occur more and more and more.